A robot must obey the orders given it by human beings except where such orders would conflict with the first law. Isaac Asimov. Respected guests, professional and student Execo members, RAS SB leads, and dear attendees. Good evening to one and all present here. We hope you all are doing well and staying safe. Robotics Around the World (RAW) is a virtual talk series conducted as per the pre-event of Droid 3.0 from IEEE FISAT RAS SP. Before we start off with the program, I would like to request all attendees to stay with us till the virtual photo session at last. Without any delays, let's begin. I invite Anita from our volunteering team to deliver the welcome address.
Anita, you are not audible.
Good evening, everyone. It gives me immense pleasure to welcome and introduce our distinguished resource person of the day, Mohammad Sainullah Khan. He is driven mechanical engineering graduate student at the University of Dayton with an impressive academic record. He is also a graduate research assistant working on projects related to the kinematics of robots and mechanisms. With over 3 years of engineering professional experience in two different industries. He has worked in various roles such as operations, maintenance, reliability, and supply chain. Amidst your busy schedule, we sincerely thank you for being with us in this session to encourage the gathering with your valuable words. I hand over the mic to you, sir.
Thank you so much, Anita. Thank you so much for having me. It is an honor for me to be here, to be invited as part of this conference. And thank you so much again. And without wasting any time, I would like to begin. So I can see that there are a lot of people here. So I would try to keep the session short and I would try to make it as interesting as possible. So my intention is to not go too deep into the nitty gritties of robotics, but rather to give you guys a general overview. So let me start out by sharing my screen. Let me know if you can see my screen. Is my screen visible?
Yes, sir.
Okay. So, in the next 30 or so minutes, this is what I'm going to cover, which would be the introduction to robotics, a very high level overview. And one thing that I added, which wasn't included as part of this talk, but I thought it would be worth your while, is I added this section, which is how you can become a roboticist. I am assuming that all of you are undergraduate students, and some of you might be in your junior year or maybe in your sophomore years as well. So I just want to give you a clear cut path how you can move forward if you want to get into the world of robotics. I would encourage if you have any questions, you can put them in the chat. And Anita or someone from the host panel, if you guys can interrupt me if someone puts their comments in the chat or their questions, and I can answer them right there and then. And secondly, I would also give you a chance at the end of the session. So if you have any questions that can be held on to later on, I would encourage that. So, as I was very generously introduced, my name is Zain, Mohammad Zainullah Khan, my full name, but I like to be called Zain. I am a graduate researcher at the University of Dayton, while also studying as a mechanical engineer. I am here in the US on a 100% fully funded scholarship, and I will be graduating next, like the end of this year. So, let's start out with a few questions. I thought we kind of I want to make this session kind of interactive. So I would love if you guys can either unmute yourself when I ask you a question, or you can just use one of these emoticons for a yes or a no. just so I can gauge at the very start how much knowledge you guys have related to robotics. I don't think I can see the emoticons on my screen. Okay. I would appreciate it if you guys can unmute yourself because for some reason I can't see the emoticons on my screen when I am sharing the screen. Okay, so the first question is, do you think your dishwasher is a robot?
No.
Anyone else? Okay, moving forward, do you think your robots are intelligent by default? Waiting for someone to speak up, or let me check the emoticons then. Okay, I think someone has raised their hand. Uh, okay, does anyone want to contribute to this question, which is, do you think robots are intelligent?
Yes.
And the third is, do we think that robots are going to take over our jobs in the next 5 years?
Absolutely.
Okay,
Yes.
so these are the three questions that we are hopefully going to tackle in the next 20 minutes. So, starting with the first question, kind of the first question, what do you hear? What do you like think of when you hear the word robot? Generally, whenever I ask this question, the image that people get in their heads is something on the left, like these robots right here, or someone who has been to the industry, he or she would think about one of these automation robots on the right, which are called robotic hands. However, these are just two of the many, many, many types of robots out there. So, this kind of gives you a more comprehensive picture of how huge the world of robotics is. It is huge. So I am going to try and go one by one through all the robots just to give you a brief idea of what these different kinds of robots are and what they do. The first one right here is a humanoid robot which resembles a human. And the ultimate objective of making this kind of a robot is to mimic the motion of a human. This one is an industrial arm robot or an industrial robot. And these are generally used in industries for pick and place operations. This one is called a hexapod robot, which looks like a spider. Um, and it is being experimented on. And one of the potential uses of this would be for search and rescue operations. This one is made by MIT, and it's called MIT Cheetah. And one of the its distinguished feature is that it can run as almost as fast as a cheetah, which is like around 3-4 times faster than humans, than the fastest human on earth. So it can run pretty fast. This one is something that we often see in our maybe in our weddings even. There's this quadcopter with a small camera attached to it, and there's the entire videography going on. So it has become very common. This one is one of the robots which was sent to Mars to gather data. So it's called a Mars rover. This looks like a snake, but it is made to specifically go underwater and grab data from underwater, such as pictures and other data that the scientists need. This one is one of the robots that is being used by Amazon. The basic objective of this robot is it goes under a shelf, and this part raises up, so it raises the entire shelf and it can move a shelf from one place to another. This one is a delivery robot. You just open the top part of it, you keep food inside of it, you close it, and it can autonomously navigate to someone's house, and it can deliver a robot. So this might be something that we might see in the coming years. This is a robotic vacuum that we all are aware of. This one right here is a pneumatically controlled robot, so you can see a pipe going here which is attached to a robot. Very simply, robot is something that does three main things. First, it does sensing. Secondly, it does computing. And third, it performs actions based on what computing and sensing it performs. So, whenever you want to think of and you need to figure out if something is a robot or not, in the very basic terms, just think of these three things: sensing, computing, and actions. If something can do all these three actions, it can be termed as a robot. We humans can be termed as a robot because we sense, our brain does the computing, and we can perform actions. Coming back to the dishwasher example. Now, if we look at it, for the sensing part, it has a built-in sensor which senses the water and the air temperature. It does computations as well. So the computations might be very basic as to when to add the detergent, when to drain out the water and stuff, but there is some computation going on. And thirdly, it performs some action, which is it dries the dishes, right? So it is a robot, although one of the very basic types. Moving forward, the classification of robots. So the classification of robots, we can basically divide robots into two broad categories: the industrial robots and the mobile robots. And then, if there is a combination of both of them, we call them cooperative robots. So within the industries, you are more than likely to find a robot similar to this one, which is the robotic hand. And they are mostly stationary robots, which may or may not be without sensors. And they have limited mobility, and they work inside of a predefined environment. So in a warehouse, you see that the warehouse is not a changing environment, it is predefined. The robot knows where it is in space, and you can at all times look at the robot. You can have camera pointing at the robot, and you can know all the parameters related to the robot. Why, on the other hand, the mobile robots are those which kind of work in a environment which isn't predefined. So let's say if you have a robot such as, let's say this one, the Mars one, you send it to Mars and you do not know the terrain of the Mars. You do not know what you will find on the Mars, right? So the way that these works, the mobile robots work, is completely different to how industrial robots work. For industrial robots, you need a lot more precision, and for mobile robots, you want to be involved with trying to figure out how the robot will interact with the surroundings, and you need to find a way for the robot not to break down, and you want to make it very robust. So for the mobile robots, you can divide them into three separate classes: the classical robots, which has wheels, chains, flying underwater; then the legged robots, such as one of the ones that I showed you here; and then there are some advanced robots, such as bio-inspired robots, and all of these. And one of the new classes that is starting to emerge is called modular robots. So what modular robots are, they are kind of a swarm robot. So there are a number of robots working together. So let's say there are 10 robots that are working together for a task, and then if need be, they can combine together to add up their computing power. So let's say if there are 10 robots which each can pick 1 kg of payload. So what if, let's say, if the payload that the encounter is maybe 5 kg, what they would do is five of them would combine together, they would come together, and they would grab the object and behave like a single robot. So that is one of the classifications of modular robots that is emerging now. So before I move on to this, Anita, do we have any questions in the chat?
I'll check, sir. 1 minute.
Yeah.
No, there aren't any questions.
Okay. And if anyone wants to like ask any question, I'm going to give you like 10 seconds to speak out if you want to. Okay, I think let's begin. So we know that robots are highly accurate, they are consistent, they never tire out, and they can work in extreme
So we have one
environments.
question.
Yeah, yes, go ahead.
The question is, sir, do you think jobs will be lost due to automation? From Abhiram Pradeep.
Ah, okay, that's a very good question, and I'm going to come to this in one of the slides later on. So hold on to that question, and when I come to that slide and I cover that, if at the end of that slide your question isn't answered, let me know, and I'm going to specifically address that. But I think that is going to be answered as part of one of the slides. But that's a very good question. Thank you for asking that. So moving forward, so we know that robots are these things, but coming back to one of the questions that I asked at the very starting, are robots intelligent? By intelligent, what we mean is, can they do stuff that they aren't specifically programmed to do? Or can they react well in changing environments, right? Like humans, we are intelligent. Why? Because even if we haven't seen something before and we encounter something very new, what we would do is we would we would count on one of the experiences of something similar in the past and use our experience to navigate through this obstacle that we have right in front of us, right? So let's say if you have a phone and a new kind of phone that you haven't seen before, and you want to unlock this phone. So, and you have never seen this phone and you aren't programmed to unlock this phone. But what you would do is, because you have used so many phones in the past, you would try pressing the buttons on the side, you would try swiping your finger up and down, and all of those things. So, you are trying to experiment, and that is what makes you intelligent. The process of experimentation and drawing up on experiences from the past on a new, never encountered before obstacle. So, can the robot do that? The answer is no. They cannot do that by default. So, in other words, robots are innately dumb. So, kind of, this is one of the questions that is very counterintuitive. One of the things that I often say, and which is counterintuitive, because people generally think that robots are very smart. And that is how the media has portrayed robots to be. But they are very dumb, very, very dumb. They can only do what they are programmed to do. But the question is, can we make them smart? But before I answer that question, how we can make them smart, I want to show you a video, which is, let me see if it comes up. Yeah. So this is one of the videos. Uh, for those who are interested in robotics, they might have already seen this video. It's from a company called Boston Dynamics, who have been involved in making robots for the past, I guess, 2 decades. And they are one of the leading makers of robots and makers and experimenters of robots. So right here you can see a humanoid robot, and let me play the video, and you can see that this robot is doing a complete parkour. It is jumping around, it is moving, it is climbing up and down the stairs, and all sorts of actions that maybe a human won't be able to perform, but it can. And now another of his buddy joins in, and now they will do something very interesting. They do a backflip. Wow. And another one. And now they even do a small celebration. So you see, when we see these kinds of videos on social media, we think that robots are very smart. They are taking over the world. They might even invade the world one day. But the thing is, if I just go back right here, there's something I want you guys to notice. Um, if I play forward to is okay, yeah. So here you can see that there is a complete protective layer which protects the humans from the robots. So you start to wonder, why did they place that? That is because these robots were specifically programmed for this task, and the way that they were programmed for this task was by using a lot of trial and error. So if you go into the Boston Dynamics website and you search on their website this video and you read upon it, you would see that it took them numerous hours just to make the robots do what you see. So it wasn't like you just give the command to a robot to do all of this and it did. There were tons and tons of failed attempts, and even after they had like figured out all the variables, even then they had to stand behind a barrier because the robots can always malfunction. So my point is that robots aren't very smart by default. They have to be programmed to do what they are supposed to be. Now the question is, how do we make them smart? So the very same way that Netflix or Google or Amazon gives you its recommendations, it uses artificial intelligence. So it uses the data that it already has, and it has a huge chunk of data, and it matches the chunk of data with your behavior, and it figures out what to recommend to you. So right here is a kind of a Venn diagram which shows you that AI and robotics were separate fields for a long time. Then what we started doing was we started bringing AI and robotics into one another. And this part is what we call artificially intelligent robots. So you see, these are robots which have a portion of AI into them. These are artificial intelligent robots. And even now you can see that a huge chunk, like I would say 90% of the robots are still not artificially intelligent. And the reason why they aren't artificial intelligence is because if you want a robot to do a repetitive task, such as a robot right here, so you don't want the robot to be artificial intelligence because all it needs to do is it needs to grab something and pick and place something here and there. And that is what it needs to do all day long, nothing else, right? So why would you want to waste time, energy, and cost on making such a robot artificial intelligence? It makes no sense. So that is why we still have a huge chunk of robots not smart, and they do what they're programmed to do, and they do that pretty well. But there is a small chunk of robots which we have now made artificially intelligent. So the question is, if they were not intelligent for decades, why are we now making them smart? Do we actually want them to conquer like our earth from us? Do we want to be destroyed by the robots? So the question is, because it is of one of our needs to make them intelligent, because we cannot do without them. So a very simple example, a real world example of why do we need to make them smart. So back in the days, when we humans as a race were very interested in exploring different planets, what we did was we thought that Mars might be a planet which might inhabit later on. So what we did was we made this robot, which is a Mars rover called Curiosity, and we sent the rover to the Mars. And the objective of this rover was it would take pictures and send those pictures back to Earth. And what we would do is we would look at those pictures and see if like the conditions look favorable to us, and just to kind of get an idea of what minerals do we have on Mars, what's the climate, and all sorts of those stuffs. But the thing is, the distance between the Earth and the Mars is huge. It is huge. So even when the communication was traveling at like the speed more than the speed of sound, it still took 12 minutes for communication to be relayed back and forth. So 12 minutes one way and 12 minutes back. So let's say if we gave the command to the rover to take a picture, the command would reach the rover 12 minutes later on, and the rover might have moved from where it was initially. And even if it did not move, it was stationary and it took a picture, it would send the picture back and we would receive it in 12 minutes, and that's like 25 minutes wasted of a highly intelligent engineer sitting in NASA, who would have wasted 25 minutes just pressing a button and waiting for the result. And that's frustrating. So what we did was we in 2016 incorporated AI into the Mars Curiosity. So what we did was we uploaded a bunch of photos of the kind of minerals that we were looking for. So we uploaded like these pictures, but thousands and thousands of pictures of potentially favorable rocks that we wanted to find on Mars. And we trained the rover's artificial intelligence system to look out for these, for anything that matches these pictures. So now it was intelligently trained, and now all it did was there was no human interference required. The robot was trained in a specific field. The robot was trained in taking photos of specific rocks, and it just went around the Mars and it took photos and it used to send them in bunches, and that saved us a lot of time. So that is one of the reasons why we are making them smart, to save our time. But again, you see that this robot, although it is intelligent, but it is only intelligent in a very specific domain, right? It was trained one in which robots become intelligent enough to solve complex puzzles and complex things. So you see, overall, if we see the potential jobs at high risk for, let's say, you guys age group would be kind of this, right? Under, I guess, 25. So 30% of the jobs are at the risk of automation, and you would be losing on to 30% of the jobs within the next 5 years. But if we look deeper into this category and we look at the education level, you can see that majority of the jobs that are being lost or will be lost are ones that require low education level. Then there are some that require medium education level, but there are very few that require high education level. So if you get past your undergrad degree, I would say you would lie somewhere in the medium to high education level. And this just shows you another view of the same thing, and it just shows you industry wise what jobs are going to be replaced by robots. So let's say if we talk about education, the potential jobs at risk of automation are very few, because in education you need to do a lot of research, and the tasks aren't so repetitive as compared to, let's say, transportation and storage, in which the tasks are very repetitive and you just need to do one single task, work in a predefined environment. So those jobs are at a high risk of automation. Similarly, if we look at here, so we can see that as we go down the, like, down this flow chart or up the ladder hierarchy wise, we can see that the jobs that are at the highest risk of automation are the ones which require almost no education, like machine operators and assemblers. And as you go up and you get into the skilled workers and professionals, the quantity of jobs that would be replaced become fewer and fewer. And I want you to read this, which is again from the report, and just reading the highlighted part, which says many of the jobs will also be created, and the long-term net effect should be positive for the economy as a whole. So when we say that robots are going to conquer our world or take over our jobs, that is going to happen, and we cannot deny that. But when that happens, that means that there would be new jobs created as well. There would be jobs created to designing of robots, developing of robots, assembling of robots, training of robots, software design of robots, programming of robots, making sensors of robots, make researching on robots, and all those sorts of jobs would be created as a result of bringing robots into the economy. And the net effect, as predicted by this report, is that it would be positive for the economy. So I hope that answers one of you guys' questions. Like, if it still doesn't, let me know and I can address it. And yeah,
So we have another question in the chat
yeah,
box.
sure, sure. Go ahead.
What it is from Srijit. What industry do you think uses the robots mostly?
Okay, that's a good question. So the I think we can just directly read from this graph only. The jobs that are at the highest risk of automations are the industries that are making most use of robots. So the transportation and storage. So this would be kind of your EVs, your electric vehicles, your autonomous vehicles that are taking over. So your transportation industry is going to be affected the most, followed by manufacturing and construction. So if I had to choose, I would say these three industries would be the ones that would be affected the most by automation?
One more question.
Yeah.
It's from Isha Pramod. So,
Mhm.
can there be new jobs generated due to the automation, like when computer first came to its field? And can you suggest some courses to prepare ourselves for automation to get those jobs used as suggested?
Isha, that's a very good question. And so, are there going to be new jobs created? Definitely. As I mentioned previously, there is going to be programming of robots, research on robots, training of robots, making new kinds of robots. And as I showed you in one of the previous slides, like the robots that we see in the industry are very few types of robots, but there is an entire world of robots out there. So those robots would gain more popularity. So there are going to be lots of jobs created. And the second part of your question is, how do we prepare ourselves for getting into this ever changing market? So that is what my second part of my presentation is for, which is, how can you get into the world of robotics? And I want you guys to be to pay special focus on this part of the presentation. Even if you were asleep during the entire presentation, just like come back to the presentation, maintain your focus here for the next 10 minutes, and I would just get done in the next 10 minutes. But this part is very important, because once you graduate, you either graduate as a software engineer, as a mechanical engineer, as a civil engineer, whatever kind of an engineer you become, you would have to transition into robotics in one form or the other in the coming 10-20 years. And there is no doubt about it. So, just to reiterate my point, no matter what kind of an engineer you become, you would have to deal with robots in the next 10 years. That is for sure. And unless you know how to make your way around, make your way with the robots, you would find yourself at a major disadvantage. So now is the time when the time is ripe and you can get into the world of robotics. You guys are still in university, you guys still have time, and you should like try setting up like half an hour or 1 hour every day and to get familiarized with the world of robotics. So broadly speaking, there are two areas that you can get into: the software side and the hardware side. Let's look at this robot right here. So this is one of the robots which is called a UR5, and it is used in an industry application. I think it is 3D printing something right here. So what would be the software side? The software side would be anything related to the software, and the hardware side is anything that you can touch and how it moves as well. So hardware side is concerned with the design and modeling of robots, while the software side is concerned with incorporating AI, machine learning, path learning, and all sorts of those crazy stuff into the robots. And you see that you cannot make a robot without the combination of both a hardware and a software, right? So in order to be a good roboticist, you need to know a bit of both. Now the question is, how do you get into those sides? So let's talk about the hardware side of robots. This right here on the left is a picture of from that I just took from one of the simulation softwares that I use. And here we can see three different robots working collaboratively on a single task. And this kind of shows you more of the hardware side of robots. So you can see how the joints will be moving. You can see the orientation, the locations, the position, and all sorts of those things. So in order to learn the hardware side of robots, you need to learn the mathematics and physics behind robots. And there is no shortcut to that. So even if you hate mathematics and physics, you would need to encounter that, and you would need to make good terms with mathematics and physics in order to get into robots. So a few of the things that you would encounter while learning the hardware side of robots would be: what are degrees of freedom of a robot, how do robots move, something called forward and inverse kinematics, Jacobian, singularities, collision avoidance, all sorts of those things. I don't want to dive deep into them, but these are just some of the things that you would encounter. Then you would decide which sensors to use and how to design industrial robots. So this is a very big point. How do you actually design industrial robots? So the way that I suggest that you start learning the hardware side is, you start by using YouTube. YouTube is a wonderful resource. You can type out any of the terms from here and you would get thousands of videos on YouTube. I too teach robotics on YouTube as well. So if any of you guys are interested, you can always go to my channel, which is this one, Engineering Simplified. And I have got two two very comprehensive playlists related to the hardware side of robots, which would take you step by step through everything that I mentioned here. And then you can always go on to and read books. Some of the books that I recommend are down here. Now coming to the software side of robots. For the software side of robots, you need to learn programming and a few softwares. For the programming, you need to learn either Python or C++. One of the two would be good enough. If you are new, I would recommend focusing more towards Python, but C++ is good enough too. Then there is something called ROS, Gazebo. These are just softwares, and these are a few of the different things that you would need to learn. And this is just MRS stands for multi robotic systems. So, like, how do you make the robots collaborate on the software side? How to begin learning again? So, you can start with learning Python. There is a wonderful course by the name of Python for Everybody. It's completely free and it has got wonderful videos and exercises. It shouldn't take you more than 20-30 hours to get done with the course, and you get a certificate out of that course. So if you don't know any programming at all, I would suggest that you start with this Python for Everybody. Just search on Google and you would get the link to this. And then you can watch videos on ROS and Gazebo. Now, what if you have zero experience? How do you begin that? Because what I mentioned was hardware and software side, and if you were watching and you had zero experience, probably if you weren't even from an engineering background, you might be intimidated by those concepts and just those terms. So let's say if you have zero experience in robotics whatsoever, you have never done anything with robots, not even remotely, not you don't even know what robots are. So how do you begin now? Before I dive into it, Anita, do we have any more questions?
Yes, sir. We have one question in the chat box.
Yeah.
From Matson Beshi, the question is, since the type of programs and codes needed for the robots mentioned before are extremely similar, can't AI be used to program new robots? So are programmers also in threat?
Okay, that's a good question. So the thing is, can AI be used to program robots? The answer is yes. AI can be used to program robots. That is the short answer. If I give you the long answer, so even though AI can program robots, and that is what Chat GPT is doing, right? But the thing is, it has got its own limitations, right? It won't give you the 100% accurate code, and unless you know what you are doing, you won't be able to get a good result. So you need to have a good amount of background, a good amount of knowledge in order to use AI to help you produce good enough results. So even though software jobs are going to be at a threat, no doubt about it, but there are going to be new jobs created, and those jobs in the software side would be related to coming up with new algorithms for intelligent systems, coming up with new methodologies for machine learning, and all sorts of those things. So for the very basic of stuff, let's say let's say a home automation system. So a home automation system is a very basic automation system, and you should be able to use an AI to write the program for a home automation system, and it shouldn't take you too long. And if you are a programmer in the home automation industry, then I think your job is going to be affected by it. But if you are working on making those algorithms, then train the artificial intelligence system on how to make home automation system, then I think you are going to be safe. I hope that answers your question. Do we have any more questions?
No, sir.
Okay, and if anyone wants to unmute themselves and speak out, feel free to do so.
Hello, sir.
Yeah.
I am Abhinav Prasad,
Yeah.
and I would like to ask the question that can't we incorporate machine learning to make robots think new ideas? and create a robot with consciousness and think like a human?
Okay, that is a good question.
Like we are training
Um,
a human, right? Like from
yeah.
18 years of college, school,
Uh-huh.
and nursery.
Uh-huh.
So can't we
Uh-huh.
train a robot like that?
We can. We can. And that is what personally worries me. We can do that. And there is
So,
no doubt about it.
sir, don't they replace the humans and their
Okay.
jobs?
Yeah. So the thing is, can they be trained like a human? Yes. So like I'm going to digress from this topic for a few minutes right now, for like 2 minutes, and I'm going to try and address your question in with regards to using Chat GPT. Right? Have you ever used Chat GPT?
Yes, sir. For my
Okay.
college projects.
Okay, perfect. So if you have used ChatGPT, you would see you type out a question and it gives you an answer, right? And sometimes it's very accurate, sometimes it gives you gibberish. So the thing is, does ChatGPT know if the answer that it is giving you is right or wrong? Do
No,
you
it
think
does
that
not.
it knows? No, it does not, right? Why?
Uh, I think it learns from experience or the data it is given.
Yeah.
But sir,
So yeah,
aren't humans also like that? Like we are
exactly.
given data from school and we process that.
Exactly. Yeah, exactly. So what people do not realize is Chat GPT is doing exactly what humans do. So let's say if you take a child and you teach a child a certain concept from the very basic, let's say you tell a child that the earth is flat, right? And you keep a child in a room and he grows to into an adulthood, and you do not let a child interact with anyone. And you just keep on hammering into the child that the earth is flat. When the child becomes an adult, he would believe that the earth is flat, right? Because that is all the data that you gave into it, and that is what ChatGPT is. So it it does produce what you tell it to. It does not know if it is right or wrong. The same as humans, we do not know for sure if we are right or wrong, right? If I tell you what is 2 plus 2, you would give me an answer 4. But how do you know 4? Because you were taught this in one of your preschool, high school, or something. But how do you know your teacher taught you correctly? You don't, right? What if the teacher was taught incorrectly? What if, like, let's say 500 years ago, the mathematics was wrong, and now we are all doing the wrong mathematics? We don't know. We think it is right, but we don't know for sure. And that is what Chat GPT is. It doesn't know for sure. So can it generate new ideas? The answer is okay. So let me put forward another question to you. Do you think you can generate new ideas?
Yes, sir. We can generate new ideas from the concept we have, or
Exactly.
yeah.
So the thing is, if you ask me, I think we cannot generate new ideas. All we do is we take experiences from the past and we merge a few experiences. They might be us merging 20,000 different experiences and concepts we have experienced, but that is what we are doing. We are taking one thing from here, one thing from here, and merging them together to come up with something creative, what we call creative, right? So that is what we are doing. We are taking things from the past and combining them. We aren't making anything new. So the thing is, everything that we do, what we call creative, is not innately creative in itself. We aren't coming up with ideas that we just get out of the blue. The ideas that we are getting and that we are implementing are those ideas which we have learned from somewhere, which we have experienced from somewhere. And that is what ChatGPT is doing. The only difference between ChatGPT and us, I would say, is probably our consciousness. It is knowing what is right or wrong, and probably being a little um, subjective, I would say, because how ChatGPT works is it is more on the objective side. It gives you a black and white kind of a picture. We humans, we are more to focus towards subjective side. So let me not digress too much from the topic, but can we train ChatGPT to become a human? The answer is no. In short, um, can it mimic what a human does? Yes, to some extent. Can it take all the jobs that humans do right now? Uh, Probably if you give it 20 years, it might be able to mimic and take over all the jobs that we do right now. But the thing is, in 20 years, we humans would have evolved a lot. And what we would be doing in 20 years, probably ChatGPT or some of the AI systems won't be able to do that. Because what we do is we take a system, we put data into it, and then we train it, right? And we humans progress faster than machines in that area because we get trained first and then we train out the machines. So yes, and we humans can do research, we can do research, and we can be subjective about research, we can do research, we can experiment new ideas, why chat gpt cannot do new research. Does that answer your question to a certain extent?
Yes, sir. Thank you.
Okay. Yeah,
So,
I
may
know
I
that
ask
is
a
a very,
question?
yeah, sure.
So, my name is Pranav Ramesh. My question is that recently I've read a lot about AI hallucinations, especially in the context of OpenAI's GPT model. So, do you think the existence of this concept of hallucinations could result in a possible subjectivity or rise of a consciousness in the AI realm?
When you talk about AI hallucination, what do you exactly refer to?
In Wikipedia, at least it's written as like you priorly you mentioned the idea that we input certain data into AI and comes out with an appropriate logically based answer. But
Yeah.
what I've understood from the concept of AI hallucinations is that um, it basically comes out with like randomly like rogue thoughts. Basically it just basically outputs extremely opposite or irrational thoughts out of the blue, and it's somewhat of a flaw which chat gpt users have come across. So do you think that might pave the way for a certain formation of a subconscious for AI?
That's a very good question. And to be honest with you, I haven't heard of the term AI hallucination before you mentioned. So thank you for mentioning that. And now that you have mentioned, it has increased my knowledge as well. And I'm going to do my research on it. But as far as I know, like the way that an AI system works is you train the AI system, right? And then it works and it gives you an output, right? And like if you look at it, AI systems aren't new, right? Like when you open Facebook, the feed that you are getting on Facebook or YouTube is all based on AI system, and even on Twitter. And one of the former founders of Twitter, I was listening to his interview, and he said that we made an AI system that would give you the perfect recommendation for feed, and it does. But now, if you ask anyone within Twitter what feed you are going to get, no one knows, right? Why? Because they trained a system, they made a system, and they let the system train itself. So you make a system and you let the system train itself, and that because like humans are limited, we have limited time, but the compute machines are very fast. So we make a machine, we give it a lot of data, and we allow the machine to train itself. And why it is training itself, you don't know what it is training on, how it is training, right? You just know the outcome of it, but you don't know how it is training. So that is, I think, how chat gpt is working. It is self training itself, right? And because we humans do not understand how it is training itself, we might be talking about it in terms of AI hallucination, which is just what I think right now. I may be wrong because I have never heard about this concept before, but that is generally how it is. It is self training itself, and because it is self training itself, no one on earth knows what is going into its, like what is going in its mind. So just to give you a very brief example, if I am a very avid chess player, and back in the days when one of the former chess champions, Gary Kasparov, he was like one of the very best chess players out there. So Gary Kasparov was challenged by IBM to play a chess game against a computer, and he did, and he lost. Right? It was a very controversial thing, but the thing is, the way that they train these chess systems, these chess AI to play chess is like right now, if you download a chess AI on your phone and you try to beat it, you can't. Even if the world's best chess player tries to beat AI right now in chess, he can't, right? So AIs are way above what humans are. How did they achieve that? Of course, if a human would have been training an AI, the AI would probably be equal to what a human is, because You can only teach what you know, right? But what we did was we did not do that. We just gave the AI the possible moves on the chessboard and what the desired outcome we wanted. So we told AI that these are the possible moves on a chessboard, and we ran it for hundreds and hundreds and hundred thousands of iterations. And in the process, it started generating new ideas. It started learning itself, and now how it works, we don't know. To be honest, we can guess how it works, but we don't know, and that is why AI is become far superior in the world of chess as compared to humans. And that is a very troubling point, because like right now no one can compete with a chess engine right now. No one can. And even if like a thousand of the best chess players sit together, they won't be able to beat a chess AI. Even a simple AI that comes on your phone, I'm not talking about those on the big mainframe computers, on your phone. So that is how powerful AI has become. But again, the thing is, chess is an environment where it gives you very objective results. If you do a certain move, this is your outcome, and it cannot waver from that, right? So only because of this criteria did AI become superior to humans, because if you do something, the outcome is predictable. In when the question is about unpredictable results, then it is still humans who win over AI systems, because we are better at using our past experiences to generate ideas, new ideas, which we call new, which are just us making use of ideas from the past, combining them. So in those areas we are better, which are not totally objective. So in those areas we still are better. In the areas which are completely objective, AI are better for sure, right? Let's say if you want to write an article, so an article would be kind of subjective, right? Because you don't know what, mm, like if you were writing an essay is kind of subjective. One person might like an essay and the other person might not like an essay. It is subjective. That is why we humans are still better than AI, because we are better at subjective things. However, if you want to talk about facts, then AI is surely better. It has got tons and tons of data. If you ask it when year was India formed, it would give you the exact year. It won't ever give you a wrong answer. Anyways, I have talked a lot on this thing, but thank you for mentioning AI hallucinations again. And I'm
Thank you,
going to
sir.
look into it. But yeah, but that is how I think it works, because
Yes, sir.
people don't know what is going on into the mind of AI. And that is very troublesome, if you ask me, because if you don't know what is going into the mind of a machine, then you don't know what is going to happen.
Yeah, it's
And
a
that
very
is the
vague
reality.
process, right?
Yeah, and that is the reality. Like the founder of Chat GPT, he is a very young guy. He is like in his 30s right now. So I was listening to his interview, and the interviewer asked him, are you afraid of Chat GPT? He was like, obviously I am probably the most afraid guy of all, right? Because he knows that even though he founded the system, he doesn't know what goes into the mind of Chat GPT. And that is exactly the reason why, like if you read onto it, chat gpt, like they did not allow chat gpt access to the entire data on the internet. They restricted a certain portion of the data on the internet from chat gpt's learning model. Why? Because they do not want any person with bad intentions to use chat gpt to generate new ideas to destroy us, right? So they have to make sure, because like if they train it on something and humans are free to do whatever they want, then the consequences can be dire. So coming back to our topic now, do we have any
Yeah.
more questions?
So we have a question from Max and Bishi. Is
Mhm.
making robots dangerous to life as well as jobs? Have heard about an oven which was programmed to have human-like memories, and when it realized that it's a microwave, it tried to kill its creator. Are we already a threat now for a mechanical revolt?
Okay, so regarding the microwave oven you have talked about, I highly doubt that is an authentic story, because because even though machines, artificial intelligent machines can realize that they are machines, right? I won't deny that they can realize that they are machines. And one of the very good experiments that was done was, what they did was they used two separate chatbots, and they allowed those artificial intelligent chatbots to interact with each other. So there was no human was sitting to a side. There were two chatbots who were interacting with each other, and within a few minutes they both realized that the other was what the machine was, an artificial intelligence system. So they are clever enough for sure, but can they kill humans? I don't think, because I don't think. Why? Because they haven't been trained on a model which makes them favorable in terms, like, which makes them more favorable as compared to a human. If if uh, if if we train, let's say, a dangerous robot on a model which in which its existence, uh, like its existence is far superior than humans existence, then maybe it would go on killing humans because it was trained that way. But unless we train it exactly that way, I don't think that is ever going to happen. So in short, robots shouldn't take over the world yet, or at least in the next 50 years, I don't think. Yeah, and now if you have any questions, just hold off for 10 minutes and we can take it on like after a couple of slides. So, and like I really like the questions that you guys have put forward. So now that shows that you are interested in this field. So if you are interested in this field and you want to dive into the world of robotics, this is how you should dive into the world of robotics. So you start by making actual robots. You, like, whatever I have told you before of watching videos, watching this, just leave everything to a side, and you start by making actual robots. How? You use a microcontroller. What is a microcontroller? A simple, it is a brain of the robot, which is, like I have shown, an Arduino. I am sure many of you might have already used this. So you use this and you make robots. What is a microcontroller? It is a brain. How difficult it is to get started? You just buy a microcontroller which is cheap and you make your first project in an hour. Would that would your first project be a robot? No, it is going to be a very simple system, but you can slowly progress to making robots. Do you need to learn any programming for this? Yes, you do need to learn a version of C language, but don't worry, you can learn it as you progress. So don't worry about it. The simplest, like, if you want to get into the world of robots, the very first thing I would recommend is you invest in something called a microcontroller, such as an Arduino. You buy it for $20-$30, probably, like, I guess 6,000 Indian rupees, 5,000 Indian rupees, not that much. And then you start building projects. So what projects can you build? You can build everything on a microcontroller. These are a few of the projects that I built. So this one on the left is a simple motor control circuit, and this took me like 20 minutes to make. This one is a light switching circuit. So there are these two buttons here. You press the button and the light switch from red, yellow, green, blue, and all the way back. So a very simple system just to get myself accustomed to it. This is a slightly more advanced thing, which is a burglar alarm system. So it is kind of a prototype of something that you would have in your house. So you start out with these projects and you get yourself accustomed to a microcontroller, and then you move on to something more advanced. So right here is one of the robots that I built recently. I would say it is a line tracking robot, kind of a object detection and a line tracking robot all in one. So here is a video of the robot. So let me play the video. So I have placed two lines here, and once the robot moves and reaches one of the lines, it would back off and go in the other direction. So right here, it goes off in the other direction. And I have also added a sensor here, which is an ultrasonic sensor. So as soon as I bring my hand close to this sensor, which is this one right here, it would stop. You see? So this is one of the projects that you can build as you advance through it. And these are robots, right? These are robots. And this is how you get into the world of robots and you start building robots. And then you can make something more complex. So this is one of the robots that I built, which is a whiteboard drawing robot. So it's a whiteboard drawing robot. You place two markers here. It has an Arduino here, and let me just fast forward this video. So you see this, like I just upload an image to this robot and it draws out this image. Do you guys know which logo is this? So this right here is a logo of MATLAB, and then these are some of the other drawings that this robot made, right? And so this is the image that I gave. This is the drawing that it made, and this is one of the image that it captured from webcam, and it draws it out. So it was a fun project, and now this is a webcam controlled rover. So you see that you start out with the very basics and you get progress along it. This is a webcam controlled rover, and it detects the area here, and it goes from here to here, and then it moves here. So if I just fast forward this video, it goes from here to here, and it just moves here. So you see that I'm not controlling the robot directly. What is happening is there is a camera placed on top, uh, which takes in the environment, and it knows where the robot is, and it guides the robot to a desired position. And so you can make more complex robots as you progress through the world of Arduino. So I would highly suggest that you start here and then you incorporate different things into it. So some of the other projects that I got from the internet are these. So right here is someone who has made a robotic hand using an Arduino. So there's an Arduino inside of this. There are a few motors here, and the robotic hand moves. So you start out with the very basics, and then you take it all the way to building real robots. So that is what I would recommend. And that takes me through the entire presentation. So thank you so much for bearing with me, and thank you so much for being here for an hour. I initially wanted this presentation to end within half an hour, but you guys asked some very good questions, so I don't regret it going that long. So here's my website. If you guys want to connect with me, you can go to this website and you can find all the links. And you can follow me on LinkedIn, and you can always subscribe to my YouTube channel if you are interested in engineering and robotics. And that brings me to the end of my session. And before I call it a day, do we have any more questions?
No, sir.
Okay.
Student
Okay.
has asked your LinkedIn profile.
Yeah. So you can just go here on my website, just take a screenshot of this, or I can probably send this presentation to one of the organizers and they can send it to all of you guys. So you can go to this website and you would get all the links to all my socials. Are there any more questions?
No, sir.
Okay. Okay. So let me stop sharing.
Thank you, sir. That was
Yeah.
indeed a noteworthy session. It was really informative, and I hope that every one of us had a great experience. Thank you so much. I
Yeah.
welcome
Thank you so much.
I welcome our guest of honor, Muhammad Zainullah Khan, to receive the memento as a token of gratitude.
Oh, thank you so much for this.
Now, we had come to the end of the session. I request all the participants to turn off your cameras on and pose for a snap with our esteemed guest. Please turn on your cameras. Now, I invite Ganesham from our volunteering team to deliver the vote of thanks.
Thank you, Hima. Very distinguished resource persons of the session. It is my pleasure to thank you for presenting us with such a wonderful session that drove us into the insights of applications of robotics and its future. On behalf of IEEE FISAT, ROS SB, We extend our heartfelt gratitude to you, sir. You showed us the path on becoming a robotics engineer. You pointed out how wide the world of robotics is and the different types of robots that exist. And for me personally, hearing you talk about swarm robots was really fascinating. You showed us how the world will change as robots continue to develop more over the years. And you showed us how it might replace the already existing markets, all the while creating new markets, which sounds just really fascinating. You talked to us about Arduino projects to become more immersed into the world of robotics and get more insights into it. And you were kind enough to show us some of your projects. Thank you so much for sparing your valuable time in guiding our attendees through the best. Let me now take a moment to extend our heartfelt gratitude to the members of Professional XCOM, the ROS SB leads, and the student volunteers who have stood as an interminable support, working hard behind the scenes to make this session a success. Lastly, but most importantly, thank you to all the attendees for your valuable presence and the enthusiastic participation. We hope that you all had a great time. Thank you.
Thank you so much.
Thank you, Ganesha. I request all the attendees to kindly fill the feedback form posted in the chat box without any fail. Thank you. Thank you all for joining us today. Hope to see you all for the upcoming events. Till then, stay connected with IEEE FISAT RAS SB. Don't forget to fill the feedback form.